Hello there, and welcome to The Sleepy Scientist, a place where curiosity slows down and knowledge becomes calm. Tonight we turn our attention beneath our feet to processes so slow and steady that they unfold beyond ordinary awareness. We will gently explore the quiet science of tectonic plates, the vast pieces of Earth's surface that drift patiently across the planet over millions of years. Before we begin, allow your body to settle. Let your shoulders soften. Let your jaw relax. Let your breathing find a natural, unforced rhythm. There is nothing you need to follow closely and nothing you need to remember. Whatever belonged to the day can begin to fade, becoming quieter with each slow breath. Tectonic plates do not rush. They move at a pace so gradual that motion feels like stillness. Continents shift by only a few centimeters each year, guided by deep forces far below the surface. Mountains rise quietly, oceans widen without sound. Change happens not through sudden effort, but through patient persistence. As we continue, we will explore the most relaxing facts about tectonic plates. We'll look at how they form, how they move, and how their slow interactions shape the surface of the Earth without urgency or intention. These are not facts meant to alarm or excite. They're facts meant to slow the mind, soften thought, and gently guide you toward rest. If you enjoy these calm journeys into the gentle side of science, you're always welcome to subscribe and return whenever the world feels loud or sleep feels distant. For now, let your attention drift downward, beneath the surface of the Earth, into a world of slow motion and quiet balance. Let's begin. Tectonic plates are vast sections of Earth's outer shell that move so slowly their motion escapes daily perception. Each plate carries continents, oceans, and landscapes across the planet at a pace similar to the growth of fingernails. This movement is steady rather than dramatic, guided by deep internal heat and gravity rather than surface forces. Over millions of years, this gentle drift reshapes the planet without urgency, allowing change to occur quietly in the background. Beneath the plates lies the mantle, a region of warm, solid rock that behaves more like thick honey than hard stone over geological time. This slow, almost fluid motion provides a calm foundation for plate movement. Instead of sudden shifts, the mantle flows patiently, transferring heat upward and guiding plates along stable paths that remain consistent across vast stretches of time. Tectonic plates rarely move in straight lines. Their paths curve gradually, responding to subtle changes in temperature and density deep within the Earth. These curved journeys are so smooth that continents appear frozen when observed over human lifespans. This slow redirection prevents abrupt changes, allowing Earth's surface to evolve without disturbance. Where plates meet, boundaries form that define how energy is exchanged. Some boundaries allow plates to slide past one another quietly, releasing tension so slowly that no noticeable change occurs at the surface. These regions demonstrate that interaction does not always lead to disruption, and that balance can be maintained through gradual adjustment rather than sudden release. Other plate boundaries gently pull apart, creating space for new material to rise from below. As molten rock cools, it becomes part of the Earth's surface, expanding ocean floors by millimeters each year. This process happens silently, far beneath the waves, adding new ground without drawing attention or demanding awareness. At converging boundaries, plates slowly meet, one easing beneath another in a process called subduction. This descent is unhurried, occurring over millions of years. The sinking plate warms gradually, releasing water and minerals into the surrounding mantle, influencing the formation of volcanoes in a calm, predictable pattern rather than chaotic eruption. Mountains often rise not through sudden force, but through patient pressure. When plates press together without subduction, layers of rock fold and lift upward centimeter by centimeter. These changes are invisible in the moment, but monumental across time, creating ranges that stand quietly for millions of years as a result of steady persistence. Earthquakes, often associated with tectonic movement, represent only brief adjustments in an otherwise calm system. Most plate motion occurs smoothly, with stress released continuously rather than suddenly. The dramatic moments are rare compared to the long periods of stillness that define tectonic behavior. The arrangement of tectonic plates has changed many times throughout Earth's history. Continents have merged and separated repeatedly, drifting apart and coming together in cycles that last hundreds of millions of years. These transformations occur without urgency, allowing ecosystems and climates to adapt gradually. Even now, tectonic plates continue their slow journey beneath the surface, shaping coastlines, mountains, and ocean basins with steady consistency. Their movement does not aim toward completion or final form. It simply continues, quietly and patiently, maintaining Earth's balance as time flows gently onward. Tectonic plates carry more than land and sea. They also carry the memory of Earth's past, preserved in layers of rock that record ancient climates, vanished oceans, and long extinct life. As plates drift, these records move with them, quietly transporting history across the planet without disturbance. Over time, fragments of distant worlds become neighbours, not through sudden change, but through patient motion that unfolds far below awareness. The edges of tectonic plates are often marked by gradual transitions rather than sharp lines. These boundary zones can stretch across hundreds of kilometres, where rock slowly bends, warms and reshapes itself. Within these wide regions, movement is distributed gently, allowing stress to spread rather than accumulate. This slow sharing of motion helps maintain balance, preventing abrupt disruption and supporting Earth's long-term stability. Oceanic plates tend to be thinner and denser than continental plates, allowing them to sink gently when they meet. This sinking does not resemble falling, but rather a controlled descent guided by gravity and temperature. As the plate moves downward, it carries surface material into deeper layers, recycling Earth's crust in a calm, continuous process that has repeated for billions of years. The formation of mid-ocean ridges illustrates how creation can occur without urgency. Along these underwater mountain chains, plates separate slowly, allowing molten rock to rise and cool. The result is a steady expansion of the ocean floor, happening quietly beneath vast depths of water. This gentle process refreshes Earth's surface without spectacle or noise. Heat within the Earth does not travel in straight lines. It rises gradually through convection, moving energy upward at a pace that supports plate motion without overwhelming it. This heat transfer is balanced and predictable, ensuring that tectonic movement remains steady rather than chaotic. The planet regulates itself through these slow exchanges, maintaining equilibrium over immense spans of time. Continental interiors often feel stable because they lie far from plate boundaries. These regions move as unified blocks, drifting smoothly without internal disturbance. This quiet stability allows landscapes to persist for millions of years with little change, reinforcing the idea that motion does not always bring visible transformation. Subduction zones demonstrate patience on a planetary scale. A descending plate may take tens of millions of years to travel from the surface into the deeper mantle. Along the way, it releases fluids slowly, altering the surrounding rock and influencing volcanic activity in a measured, predictable pattern. Each step of this descent unfolds gradually, guided by consistent physical laws. Volcanic arcs formed above subduction zones do not erupt constantly. Instead, magma accumulates slowly, sometimes over thousands of years before reaching the surface. Much of the time, these systems remain quiet, releasing heat gently into surrounding rock. The visible eruptions are brief moments within much longer periods of calm preparation. The movement of tectonic plates influences ocean currents and atmospheric patterns over geological time. As continents shift, gateways open and close, subtly redirecting water and airflow. These changes occur gradually, allowing climates to adapt without sudden shock. Earth systems respond together, maintaining harmony through slow adjustment. Even now, tectonic plates continue to glide across the mantle with quiet persistence. Their motion does not aim toward completion or final arrangement. It remains ongoing, steady, and unhurried, shaping the planet gently while leaving space for everything above to rest, evolve, and remain in balance. Tectonic plates move in response to forces that are evenly distributed deep within the Earth. Rather than being pushed or pulled abruptly, they respond to subtle differences in temperature and density that develop slowly over time. Warmer regions of the mantle rise gently, while cooler regions sink, creating a quiet circulation that guides plates along stable paths. This motion is so gradual that it allows the planet to remain calm and balanced, even as change continues. The surface of the Earth appears solid and still, yet it rests on a foundation that is always in motion. This motion is not chaotic. It follows patterns that repeat over millions of years, allowing landscapes to form, erode, and reform without urgency. Valleys deepen slowly. Plateaus rise almost imperceptibly. The Earth reshapes itself with patience rather than force. Large continental plates often contain smaller fragments known as microplates. These smaller pieces move gently between larger plates, absorbing motion and distributing stress. Their presence allows movement to remain smooth and controlled, preventing sudden shifts. In this way, even complexity contributes to calm, helping the planet maintain long-term stability. Sediments carried by rivers eventually reach the edges of tectonic plates, where they settle quietly at boundaries. Over time, these layers are compressed and transformed into rock, becoming part of the moving plate itself. This process is slow and continuous, turning soft material into solid structure without disruption, preserving a sense of gradual order. The age of tectonic plates varies across the planet. Oceanic crust is constantly renewed, rarely exceeding a few 100 million years in age, while continental crust can persist for billions of years. This contrast allows the Earth to balance renewal and preservation at the same time. Nothing is rushed and nothing is erased suddenly. Plate movement influences sea level over long periods. As plates rise or sink, coastlines shift gently, allowing oceans to advance or retreat without urgency. These changes unfold slowly enough for ecosystems to adapt naturally, maintaining continuity rather than disruption. Shorelines migrate over centuries and millennia, guided by steady geological motion. The thickness of tectonic plates affects how they respond to forces beneath them. Thicker regions resist bending, maintaining stability, while thinner regions flex gently. This variation allows stress to be shared across wide areas, preventing concentration and maintaining balance. The Earth distributes movement in a way that favors calm adjustment. Beneath mountain ranges, tectonic plates can extend downward into deep roots that stabilize the surface above. These roots form gradually as material thickens and cools, anchoring mountains quietly in place. This hidden support allows towering landscapes to remain steady for millions of years without collapse or sudden change. The interaction between tectonic plates and Earth's rotation subtly influences their motion. While rotation does not drive plate movement directly, it affects the distribution of mass within the planet. These effects remain gentle and secondary, contributing to the overall balance rather than overpowering it. The Earth's systems work together quietly, each influence remaining in proportion. As tectonic plates continue their slow journey, they do not signal an endpoint or final arrangement. Continents will continue to drift, oceans will continue to open and close, and mountains will rise and soften over time. This ongoing motion remains calm and unhurried, allowing the planet to change while preserving a steady sense of balance beneath everything that rests upon its surface. Tectonic plates do not move independently of one another. Each plate's motion is influenced by the movement of those around it, creating a connected system where balance is shared rather than isolated. When one plate adjusts its path slightly, neighbouring plates respond gradually, redistributing motion across wide regions. This interconnected behaviour allows the planet to absorb change without concentrating stress in a single place. Deep beneath the oceans, vast stretches of crust slide quietly over the mantle, unseen and unheard. These movements do not disturb the water above them. Waves continue their familiar rhythms while the ground below drifts slowly, reminding us that multiple layers of motion can coexist without interfering with one another. The ocean remains calm even as the earth beneath it continues its steady journey. Over millions of years, tectonic plate motion reshapes continents without altering their identity all at once. A coastline may shift slightly, a plateau may rise, or a basin may deepen, but these changes blend into the landscape so gradually that they feel natural rather than imposed. The earth adjusts itself gently, allowing continuity rather than a disruption. The friction between tectonic plates is often low enough to allow smooth sliding. In these regions, plates glide past one another at a pace so slow that energy is released continuously instead of building up. This steady release prevents sudden movement, maintaining a quiet equilibrium where motion occurs without dramatic consequence. Beneath sedimentary layers, plates carry vast thicknesses of rock that behave differently depending on pressure and temperature. At depth, rock bends instead of breaking, flowing slowly under stress. This ability to bend allows tectonic motion to remain calm and distributed, preventing sharp boundaries and encouraging gradual transformation. Tectonic plates influence the distribution of natural resources over long periods. Minerals concentrate slowly as plates move, collide, and separate. These processes unfold quietly, guided by heat and pressure rather than force. Over time, regions become enriched without sudden change, demonstrating how abundance can emerge through patience. The slow drift of plates also affects Earth's magnetic history. As molten rock rises and cools at plate boundaries, magnetic minerals align with the planet's magnetic field, preserving a gentle record of direction and movement. These records accumulate silently, layer by layer, offering a calm timeline of Earth's shifting surface. Plate motion contributes to the formation of long, stable landmasses called cratons. These ancient regions resist deformation and move as solid units across the mantle. Their stability provides a quiet foundation upon which ecosystems develop and persist, largely unaffected by the subtle motion beneath them. The boundaries between plates often host long periods of stillness. Even in regions known for tectonic activity, years or centuries may pass without noticeable change. During these times, stress redistributes slowly and the system remains balanced. Stillness, rather than activity, defines most of tectonic history. As tectonic plates continue their movement, they do so without awareness of outcome or destination. There is no final arrangement they seek to reach. Motion continues simply because it is supported by deep, steady forces within the Earth. This quiet persistence allows the planet to remain dynamic yet calm, changing gently while preserving balance beneath every surface landscape. Tectonic plates move in ways that allow the Earth to release internal heat without disturbance. Heat rising from deep within the planet is transferred upward through slow convection rather than sudden bursts. This gradual movement helps regulate the planet's temperature over immense spans of time, ensuring that internal energy escapes evenly and calmly rather than building up in a single place. The meeting points of tectonic plates often become places where the Earth quietly reshapes itself. Rock bends, warms, and transforms slowly under pressure, changing its form without breaking. This slow transformation allows landscapes to evolve without disruption, showing how flexibility at depth supports stability at the surface. Beneath large sedimentary basins, tectonic plates sink almost imperceptibly under the weight above them. This sinking happens gradually, allowing layers of sediment to accumulate evenly. Over time, these basins become archives of Earth's history, formed not by collapse but by patient adjustment that unfolds quietly over millions of years. The slow pace of tectonic movement allows life on Earth to adapt smoothly to changing conditions. As continents drift, climates shift gradually, giving ecosystems time to respond. Forests migrate, oceans adjust, and species evolve without sudden shock, demonstrating how gentle geological motion supports biological balance. Tectonic plates also influence the long-term circulation of carbon within the Earth. As plates move, carbon-bearing rocks are carried into the mantle and later returned to the surface through slow volcanic processes. This exchange occurs steadily, helping regulate atmospheric composition over geological time without abrupt changes. The thickness of tectonic plates varies across the planet, and this variation contributes to calm motion. Thicker sections resist bending and remain stable, while thinner areas flex gently. This difference allows stress to be shared across wide regions, preventing concentration and maintaining overall balance within the system. Plate motion beneath ice-covered regions continues quietly, unaffected by surface conditions. Glaciers advance and retreat above, while the plates below move at their steady pace. These layered motions coexist without conflict, reminding us that the Earth operates through multiple rhythms at once, each unfolding calmly. Over long periods, tectonic plates can cause entire ocean basins to slowly close. As plates converge, oceans narrow millimeter by millimeter, allowing coastlines to draw closer over millions of years. This process happens without urgency, giving the planet time to adjust its circulation and climate gradually. The movement of plates also influences the height of continents. As plates thicken or thin, land rises or settles gently. These changes occur so slowly that landscapes appear stable, even as they adjust continuously beneath the surface. Elevation becomes a quiet response to deep forces rather than a sudden event. Even now, tectonic plates continue their steady motion beneath the Earth's surface, guided by heat, gravity, and time. Their movement does not seek an ending or final shape. It simply continues, patient and balanced, allowing the planet to remain alive with motion while preserving a deep sense of calm beneath everything that rests upon it. Tectonic plates respond to gravity in a way that encourages balance rather than strain. As denser sections of a plate cool and sink slightly, lighter regions rise just enough to maintain equilibrium. This quiet adjustment happens continuously, allowing the planet to redistribute mass gently without drawing attention to the process. The edges of continents often sit atop thick, buoyant portions of tectonic plates that resist sinking. These stable regions drift slowly across the mantle, preserving landforms for millions of years. Rivers carve valleys and winds shape surfaces above, while the plate beneath continues its patient movement, unchanged by surface activity. At great depths, pressure transforms rock into materials that can stretch and flow without breaking. This flexibility allows tectonic plates to bend slowly rather than fracture, reducing stress and encouraging smooth motion. Change occurs through reshaping rather than rupture, supporting calm continuity within the Earth. The creation of deep ocean trenches occurs gradually as one plate slides beneath another. These trenches deepen over long periods, centimetre by centimetre, forming some of the quietest and most remote places on Earth. Water above remains undisturbed, while the descent below continues silently. Tectonic plates influence the placement of long volcanic chains that form as plates drift over stationary heat sources deep within the mantle. As the plate moves, volcanoes form one by one, creating a trail that marks slow motion across millions of years. Each volcano forms quietly, adding to a record of steady movement rather than sudden change. The Earth's crust thickens slowly where plates compress, adding strength and stability to regions under pressure. This thickening does not force land upward suddenly. Instead, it supports gradual uplift that unfolds over immense spans of time, allowing landscapes to adjust gently without disruption. Plate motion beneath shallow seas causes gradual changes in water depth that influence marine life calmly. Coral reefs rise slowly with the seafloor, and marine ecosystems adapt naturally to shifting conditions. This quiet adjustment demonstrates how geological motion and life remain in harmony through patience. The slow movement of tectonic plates also affects Earth's long-term tilt and balance. As mass redistributes across the surface, the planet responds subtly, maintaining rotational stability. These changes are small and evenly spread, reinforcing calm rather than creating imbalance. Many plate boundaries experience long intervals of complete stillness at the surface. Beneath this apparent quiet, stress redistributes slowly and evenly. The absence of visible motion does not indicate inactivity, but rather a system that is releasing energy continuously without disturbance. As tectonic plates continue their steady journey, they do so without urgency or direction. Their movement remains guided by deep, constant forces that operate beyond immediate awareness. This quiet persistence allows Earth to remain dynamic yet peaceful, changing gently beneath the surface while everything above rests, grows, and settles into its own calm rhythm. Tectonic plates glide across the mantle in response to forces that remain steady rather than changing. These forces do not increase suddenly or fade unexpectedly. They persist at nearly constant levels over millions of years, allowing plate motion to remain smooth and predictable. This consistency prevents abrupt shifts and supports a calm, ongoing balance within the Earth. The mantle beneath tectonic plates behaves in a way that softens motion. Though solid, it deforms slowly under pressure, allowing plates to move without friction that would otherwise cause sudden resistance. This slow deformation acts like a cushion, absorbing stress and guiding movement gently rather than forcing it. As plates move, they carry entire ecosystems across latitudes over geological time. Forests, deserts, and coastlines migrate gradually as continents drift. These changes occur so slowly that life adapts naturally, maintaining continuity rather than facing disruption. Movement becomes a quiet transition rather than a dramatic shift. The thickness of continental crust provides insulation that slows heat transfer from below. This insulation helps maintain stable conditions at the surface even as plates move. Temperature changes remain gradual, reinforcing calm environmental evolution rather than sudden transformation. Beneath large mountain ranges, tectonic plates can spread outward slightly, redistributing mass and pressure. This spreading happens over long periods, preventing the buildup of stress. Mountains remain stable not because they are fixed, but because motion beneath them is shared gently across wide areas. The slow recycling of crust through plate motion allows Earth to renew itself continuously. Old oceanic crust sinks gradually into the mantle, while new crust forms elsewhere at an equal pace. This balance between removal and creation keeps the planet's surface fresh, without ever feeling abrupt or incomplete. The boundaries between plates often shift position over time. A boundary that was once active may become quiet while motion relocates elsewhere. This migration occurs gradually, ensuring that tectonic energy remains distributed rather than concentrated. Calm is preserved through movement rather than stillness. Water carried into the mantle by subducting plates is released slowly, influencing the melting of surrounding rock. This process feeds volcanic systems gently over long periods, allowing magma to form without pressure buildup. The resulting activity follows predictable cycles rather than sudden outbursts. Tectonic plates also influence Earth's long-term shape by redistributing mass across the surface. As continents drift and collide, the planet adjusts subtly, maintaining balance in its rotation. These adjustments occur smoothly, ensuring stability rather than imbalance. Even now, tectonic plates continue their quiet movement beneath the Earth's surface, guided by forces that operate patiently and evenly. There is no rush, no destination, and no final arrangement. Motion persists calmly, allowing the planet to change while remaining deeply balanced, steady beneath every landscape and ocean above. Tectonic plates move in a way that allows Earth's surface to remain mostly calm for long periods. Although the plates are always in motion, most of that movement is spread evenly across vast areas. This distribution prevents sudden change and allows the planet to adjust slowly, maintaining a steady balance beneath oceans, plains, and mountains alike. The boundaries between tectonic plates often become zones of gradual transformation rather than sharp separation. Within these regions, rock warms, bends, and reshapes itself over time. Instead of breaking suddenly, materials adjust slowly, allowing stress to dissipate gently. This soft transition supports stability at the surface, even while deep motion continues. As plates drift, they influence the position of continents relative to the Sun. Over millions of years, land masses move through different climate zones, allowing temperatures and ecosystems to shift gradually. These slow changes give life time to adapt, reinforcing harmony between geological motion and biological rhythm. The slow uplift of land caused by tectonic forces can change river paths without disruption. Rivers respond calmly, adjusting their courses over centuries and millennia. Valleys deepen or widen gently, guided by gravity and time rather than force, creating landscapes that feel settled and balanced. Beneath the seafloor, tectonic plates support the formation of wide, flat abyssal plains. These regions develop as sediments settle slowly over moving crust, smoothing the surface over millions of years. The result is one of the most tranquil environments on Earth, formed through patience rather than activity. Tectonic plate motion also influences the long-term distribution of fresh water. As land rises or settles gradually, drainage patterns shift, allowing lakes to form or fade slowly. These changes unfold gently, ensuring continuity rather than sudden loss or creation. The interaction between tectonic plates and Earth's gravity helps maintain the planet's overall shape. As plates move and redistribute mass, the Earth responds subtly, preserving equilibrium. These adjustments are small and continuous, reinforcing stability rather than altering balance. In many regions, tectonic plates move beneath thick layers of sediment that act as insulation. This insulation slows the transfer of stress and heat, softening motion below the surface. The presence of these layers allows tectonic movement to remain calm and controlled. Plate motion beneath ancient continents often becomes slower and more stable over time. These old regions, known for their strength, drift quietly across the mantle with little internal change. Their stability provides a calm foundation for life and climate to persist over long spans of time. As tectonic plates continue their patient journey, their motion remains guided by deep forces that do not hurry. Continents will continue to drift, oceans will continue to reshape, and mountains will slowly change, all without urgency. This quiet persistence allows Earth to remain active yet peaceful, changing gently while maintaining a deep sense of balance beneath every surface. Tectonic plates influence the slow shaping of Earth's interior as much as its surface. As plates move, pressure deep below adjusts gradually, allowing minerals to change structure over immense spans of time. These transformations happen silently, guided by steady heat and compression rather than sudden force, contributing to the planet's long-term balance. The slow bending of tectonic plates near their edges creates broad regions of gentle curvature rather than sharp breaks. This bending absorbs motion smoothly, reducing stress and allowing plates to continue their movement without interruption. The Earth prefers gradual adjustment, choosing flexibility over resistance whenever possible. Over millions of years, tectonic motion helps regulate Earth's atmosphere indirectly. As continents shift, weathering patterns change slowly, influencing how carbon is absorbed and released. These exchanges occur patiently, helping maintain atmospheric stability without sudden fluctuations. Beneath ancient ocean floors, tectonic plates carry thick layers of sediment that settle gradually. These layers act as quiet record keepers, preserving traces of past climates and ocean conditions. The slow accumulation of these sediments mirrors the steady pace of plate motion itself. The calm movement of tectonic plates allows Earth's internal heat to escape evenly across the planet. Rather than concentrating in one place, heat is released gradually through widespread processes. This steady release prevents extremes, supporting long-term planetary comfort and balance. The boundaries between tectonic plates can shift position over time, migrating slowly across regions. As this happens, areas that were once active may become calm while motion relocates elsewhere. This gradual redistribution ensures that tectonic energy remains spread out, preventing prolonged concentration in any single region. The slow motion of plates beneath shallow seas influences the formation of wide continental shelves. These shelves develop gently as land settles or rises over millions of years, creating stable environments where marine life thrives calmly and consistently. Tectonic plates help shape Earth's gravitational balance by redistributing mass slowly across the surface. As continents drift, the planet responds subtly, maintaining equilibrium. These adjustments are quiet and continuous, ensuring stability rather than disruption. In many regions, tectonic plates move beneath thick forests, deserts, and plains without affecting life above. The surface remains calm while deep motion continues. This separation of scales allows the Earth to change internally while preserving tranquility at the surface. As tectonic plates continue their slow journey, their movement remains steady and unhurried. There is no final destination and no moment of completion. The motion simply persists, guided by deep forces that operate patiently, allowing the planet to evolve gently while maintaining a profound sense of calm beneath everything that rests upon it. Tectonic plates contribute to the long-term stability of Earth by allowing stress to be released gradually rather than stored indefinitely. Most of the time, movement occurs through tiny adjustments that happen continuously at depth. These small shifts prevent large imbalances from forming, allowing the planet to remain calm and resilient over immense spans of time. The slow migration of plates influences the depth and shape of ocean basins. As plates cool and move away from mid-ocean ridges, they settle gently, allowing the seafloor to deepen over millions of years. This gradual settling creates broad, stable basins that hold oceans in quiet balance without sudden change. Tectonic motion also affects how heat is stored within the Earth. Plates act as insulating layers, slowing the escape of internal warmth. This controlled release ensures that the planet cools gradually, maintaining internal activity without rapid loss of energy. The result is a steady, enduring system rather than one driven by extremes. As plates drift, they carry ancient rocks across the planet, preserving them far from where they formed. These rocks remain largely unchanged during their long journey, demonstrating how motion does not always require transformation. The Earth moves its history gently, allowing the past to remain intact. The slow compression and extension of tectonic plates influence the formation of long, shallow basins where sediments can accumulate peacefully. Over time, these basins become broad, flat landscapes shaped by patience rather than force. Rivers and winds work alongside tectonics, each operating at its own gentle pace. The interaction between tectonic plates and Earth's deep water cycle unfolds quietly. Water carried into the mantle by subducting plates is released slowly, influencing melting and rock formation over long periods. This gradual exchange helps regulate internal processes without creating imbalance. In regions far from plate boundaries, the crust experiences little stress. These stable interiors drift calmly across the mantle, allowing surface features to remain unchanged for millions of years. This stillness offers a sense of permanence, even as slow motion continues beneath. Tectonic plates help distribute Earth's mass in a way that supports rotational stability. As continents drift and collide, the planet subtly adjusts, maintaining balance without noticeable effect. These adjustments are gentle and continuous, reinforcing calm rather than disruption. The slow pace of tectonic movement allows erosion and deposition to keep pace with uplift and subsidence. Mountains rise slowly enough for wind and water to shape them gradually, maintaining harmony between construction and erosion. The landscape evolves smoothly, without sharp contrast. Even now, tectonic plates continue their patient motion beneath the surface, guided by steady heat and gravity. Their movement does not signal an end or a beginning. It simply persists, quiet and unhurried, allowing the Earth to remain alive with motion while preserving a deep and lasting sense of calm. Tectonic plates help regulate the Earth's surface by allowing elevation changes to occur gradually. As plates thicken or thin over time, land rises or settles gently, giving landscapes time to adjust. Hills form slowly, plains expand patiently, and coastlines shift without disruption. This slow adjustment maintains balance rather than forcing sudden change. The movement of plates beneath large river systems influences how water finds its path. As land tilts or settles gradually, rivers respond calmly, altering their courses over long periods. These changes happen so slowly that ecosystems adapt without stress, maintaining continuity between land and water. Tectonic plates also shape the distribution of Earth's deep heat in a way that prevents concentration. Instead of allowing heat to collect in one area, plate motion spreads it evenly across the planet. This distribution supports long-term stability, ensuring that internal energy is released steadily rather than abruptly. Beneath sediment-covered regions, plates experience softened motion. Thick layers of sediment absorb stress and insulate heat, allowing plates to move smoothly below. This buffering effect reduces tension and promotes calm adjustment, keeping motion gentle and controlled. As plates drift apart at spreading centers, new crust forms slowly and evenly. Molten rock cools at a measured pace, solidifying into fresh surface without turbulence. This quiet creation process refreshes the planet continuously, allowing renewal to occur without urgency or spectacle. The long-term drift of tectonic plates influences the orientation of mountain ranges relative to prevailing winds. Over millions of years, this affects rainfall patterns gently, guiding climates into new arrangements without sudden shifts. These transitions unfold patiently, preserving environmental balance. Tectonic plates also contribute to Earth's long memory. Rocks carried across continents preserve records of ancient environments, locked in place as plates move. This quiet transport allows history to travel intact, blending past and present without disruption. The steady nature of plate motion helps maintain Earth's shape over time. As mass shifts slowly across the surface, the planet adjusts subtly, preserving equilibrium. These small adjustments happen continuously, ensuring stability rather than imbalance. In regions where plates move slowly, stress dissipates over wide areas instead of building up. This spreading of motion allows the Earth to remain calm, preventing sudden changes and supporting long periods of stillness at the surface. As tectonic plates continue their quiet journey, their movement remains guided by deep forces that do not hurry. There is no final arrangement they seek, only ongoing balance. The motion persists gently, allowing the Earth to evolve while maintaining a steady sense of calm beneath every landscape and ocean. Tectonic plates play a quiet role in shaping Earth's long-term surface stability by redistributing weight gradually. As plates move, mass shifts slowly across the planet, allowing gravity to remain balanced. This redistribution happens evenly, preventing sudden tilting or strain and helping Earth maintain its steady form over immense spans of time. The slow movement of plates beneath volcanic regions allows heat to escape without overwhelming the surface. Magma rises gradually, transferring energy upward in a controlled way. Much of this heat never reaches the surface at all, instead warming surrounding rock gently and maintaining internal balance rather than dramatic activity. Tectonic motion beneath shallow seas allows coral reefs and marine ecosystems to adjust calmly to changing conditions. As land rises or settles millimeter by millimeter, reefs grow upward at a similar pace, keeping their position within sunlight. This quiet coordination between geology and life unfolds without urgency. The interaction between plates and sediment layers creates wide regions of gradual deformation rather than sharp boundaries. Sediments compress slowly, absorbing stress and smoothing motion. This soft response allows tectonic forces to be spread gently across large areas, reducing strain and maintaining calm beneath the surface. As plates drift across the mantle, they encounter regions of varying temperature. These changes influence speed slightly, causing plates to slow or accelerate just enough to preserve balance. This self-regulating behavior ensures motion remains smooth rather than uneven. Tectonic plates also influence the distribution of nutrients over geological time. As land rises and erodes slowly, minerals are released into oceans and soils at a steady pace. This gradual supply supports ecosystems without sudden abundance or scarcity, reinforcing long-term balance. The slow convergence of plates can thicken crust beneath continents, strengthening the land over time. This thickening happens quietly, providing support rather than stress. As a result, continents remain stable and resilient, capable of carrying life for millions of years without interruption. Beneath ancient plate interiors, movement becomes increasingly subtle. These regions drift as unified blocks, experiencing little internal change. Their calm persistence provides a foundation of stability that contrasts gently with the slow motion occurring at plate boundaries. Tectonic plates help moderate Earth's response to internal heat by allowing expansion and contraction to occur gradually. Instead of building pressure, the planet adjusts continuously, preventing sudden release. This steady response contributes to Earth's long-term calm. As tectonic plates continue their patient motion, they remain guided by forces that operate quietly and evenly. There is no moment of completion and no final arrangement. The movement simply continues, slow and balanced, allowing Earth to remain dynamic while preserving a deep, underlying sense of stillness. Tectonic plates influence the way Earth's surface responds to weight over long periods of time. As glaciers grow and melt or seas advance and retreat, the crust adjusts slowly, rising or settling millimeter by millimeter. This gradual response prevents sudden shifts, allowing the planet to maintain balance as conditions change gently above. The slow movement of plates beneath deserts and plains often goes completely unnoticed. Sand dunes shift, winds pass, and seasons change while the ground below continues its patient drift. This layered stillness shows how surface calm and deep motion can exist together without interference. Tectonic plates help determine where long-lasting freshwater systems develop. As land subtly tilts or lifts, water collects in basins that form slowly and remain stable for thousands of years. Lakes and wetlands appear not through sudden change, but through gradual shaping that encourages continuity. The boundaries between tectonic plates can become zones of quiet heat exchange, Warm rock transfers energy gently into cooler surroundings, equalizing temperature without abrupt contrast. This steady exchange supports long-term stability within the crust and mantle. As plates migrate, they alter the position of continents relative to ocean currents. These shifts occur slowly, allowing currents to adjust without disruption. Over time, new circulation patterns form, influencing climate in a way that remains smooth and predictable. Tectonic plates also influence the height of seafloors over geological time. As oceanic crust cools and thickens, it settles slightly, deepening the oceans gradually. This slow settling allows marine environments to adapt without sudden pressure or loss. Beneath forested regions, plate motion continues quietly, unaffected by surface life. Roots grow, soils develop, and ecosystems thrive while the crust below drifts calmly. This separation of timescales allows life to remain stable while the Earth reshapes itself slowly. The movement of plates can create long, gentle slopes that guide rivers without forcing sudden changes. Water follows these slopes naturally, carving channels over millennia rather than moments. The result is a landscape shaped through cooperation between geology and water. Tectonic plates also influence the long-term distribution of volcanic ash and fertile soils. As land rises and erodes gradually, nutrients spread slowly across regions, enriching ecosystems without overwhelming them. This process unfolds patiently, supporting life through balance. As tectonic plates continue their steady journey, they do so without anticipation or destination. Their motion remains constant, guided by deep forces that act quietly and evenly. Change continues, slow and gentle, allowing the Earth to remain active while preserving a profound sense of calm beneath everything that rests upon it. Tectonic plates influence how Earth slowly adjusts to long-term changes in surface weight. When large ice sheets grow or retreat, the crust responds gradually, lifting or settling over thousands of years. This gentle rebound happens so slowly that it feels like stillness, allowing balance to be restored without disturbance. The slow drift of tectonic plates beneath ancient seabeds helps preserve layers of sediment that record Earth's history. These layers accumulate patiently, one atop another, forming a calm archive of changing oceans, climates, and life. Nothing is rushed. Each layer settles when it is ready. Tectonic motion beneath wide continental plains often creates subtle tilts that guide groundwater movement. Water flows quietly through underground layers, forming aquifers that remain stable for centuries. These hidden systems develop through patience rather than force, supporting life gently from below. The gradual compression of plates can strengthen regions of the crust over long periods. As rock is pressed slowly, it becomes more resilient, capable of supporting landscapes without cracking or collapse. This quiet strengthening reinforces Earth's stability without visible change. Tectonic plates also shape the long-term position of fertile river deltas. As land rises or settles imperceptibly, rivers adjust their outlets calmly. Sediment spreads gently into the sea, forming new land slowly, allowing ecosystems to establish themselves without urgency. The slow movement of plates beneath polar regions continues uninterrupted by surface cold. Ice sheets advance and retreat above, while deep motion persists at its steady pace. These layered rhythms coexist peacefully, each operating on its own timescale without interference. Tectonic plates help distribute Earth's internal pressure evenly. Instead of allowing stress to accumulate in one place, motion spreads it gently across wide regions. This distribution maintains calm within the planet, preventing extremes and encouraging balance. As plates migrate, they influence where long volcanic plateaus form. Lava spreads gradually over vast areas, cooling slowly and creating stable landforms that persist for millions of years. These plateaus form not through sudden events, but through repeated gentle processes. The movement of tectonic plates can subtly alter Earth's coastline shape over long periods. Bays widen, peninsulas soften, and islands shift position gradually. These changes unfold so slowly that coastlines appear timeless, even as they continue to evolve. As tectonic plates continue their patient motion, they remain guided by forces that act quietly and evenly. There is no final shape they are moving toward, only ongoing balance. The Earth continues to change gently, maintaining calm beneath every ocean, continent, and sky above. Tectonic plates play a subtle role in shaping Earth's long-term balance by adjusting slowly to internal and external forces. As the mantle beneath them warms or cools, plates respond with gentle shifts rather than sudden motion. This quiet responsiveness allows the planet to maintain equilibrium without creating stress at the surface. The slow motion of plates beneath broad continental interiors contributes to long periods of geological calm. These regions experience little visible change because motion is spread evenly across vast areas. The surface remains stable while deep forces continue their steady work far below. Tectonic plates influence how sediment is distributed across continents over time. As land rises or settles imperceptibly, rivers and winds transport material gently, allowing soils to form and reform without disruption. This gradual process supports stable landscapes and long-lasting ecosystems. The interaction between tectonic plates and deep crustal rocks allows heat to be stored and released gradually. Instead of escaping quickly, warmth moves slowly upward, softening rock and enabling motion to remain smooth. This controlled transfer of energy supports calm geological processes rather than dramatic change. As plates drift, they subtly affect the orientation of mountain ranges relative to prevailing winds. Over millions of years, this influences rainfall patterns gently, shaping climates without sudden shifts. The atmosphere and solid Earth respond together in a quiet, coordinated way. Tectonic plates also help regulate the depth of Earth's oceans over long spans of time. As oceanic crust cools and thickens, it sinks gradually, allowing water to settle into stable basins. This slow adjustment maintains balance within the global ocean system. Beneath volcanic islands, plates continue their steady movement even as lava cools above. Islands form layer by layer, with each eruption adding gently to the surface. The plate below carries these islands calmly across the mantle, preserving their shape over millions of years. The slow convergence of plates beneath continents can strengthen the crust by thickening it gradually. This strengthening provides support without forcing rapid uplift. Mountains rise slowly, supported by deep roots that grow quietly over time. Tectonic plates influence Earth's long-term response to erosion. As land is worn away at the surface, plates adjust subtly below, maintaining balance. This quiet compensation ensures that landscapes change smoothly rather than collapsing suddenly. As tectonic plates continue their patient journey, their movement remains guided by deep forces that operate without haste. There is no final stage or moment of completion ahead. Motion continues gently and steadily, allowing the Earth to remain dynamic while preserving a deep and lasting sense of calm beneath everything that rests upon it. Tectonic plates influence the way Earth quietly corrects itself after long periods of surface change. When erosion removes material from mountains over millions of years, the crust beneath responds slowly, rising just enough to maintain balance. This process happens gradually, allowing landscapes to remain stable even as they are gently reshaped by wind and water. The slow movement of tectonic plates beneath wide grasslands and plains helps preserve their openness. These regions experience little deformation because motion is distributed evenly at depth. The surface remains calm and expansive, while the plate below continues its steady drift without drawing attention to itself. Tectonic plates help guide the formation of long, shallow seas that persist for millions of years. As land settles gently or rises slightly, water fills low regions without urgency. These seas become stable environments where life adapts slowly, supported by the quiet rhythm of geological motion. The interaction between plates and Earth's deep interior allows pressure to be released gradually through bending rather than breaking. Rock changes shape slowly under stress, flowing over time instead of fracturing. This ability to adjust quietly helps prevent sudden disruption and supports long-term calm within the planet. As plates move, they influence where thick soils develop over long periods. Gentle uplift and subsidence guide erosion and deposition, allowing fertile layers to form patiently. This slow soil development supports ecosystems without sudden change, reinforcing continuity between geology and life. Tectonic plates also affect the long-term stability of Earth's rotation by redistributing mass gradually. As continents drift and collide, the planet adjusts subtly, maintaining equilibrium. These adjustments are small and continuous, ensuring balance without noticeable effect at the surface. Beneath ancient mountain ranges, tectonic plates continue to flow slowly, even after uplift has ended. These deep motions help support mountains longer after their formation, allowing them to persist quietly for millions of years while erosion works gently above. The slow pace of tectonic movement allows heat to be shared evenly across the crust. Instead of concentrating in one place, warmth spreads gradually, preventing extremes. This steady distribution supports calm geological conditions and long-term planetary comfort. Tectonic plates help shape the quiet boundaries between land and sea by guiding gradual changes in elevation. Coastlines evolve softly, smoothing sharp edges and creating gentle curves over time. These transitions unfold so slowly that they feel timeless, even as they continue to change. As tectonic plates continue their steady motion beneath the Earth's surface, they do so without urgency, intention, or destination. Their movement remains patient and balanced, guided by deep forces that act quietly and consistently. Change continues gently, allowing the planet to remain alive with motion while preserving a deep and enduring sense of calm. Tectonic plates quietly influence the way Earth absorbs and redistributes long-term stress. Instead of allowing pressure to build sharply, the planet responds through slow bending and gradual movement. This steady adjustment spreads energy across wide regions, allowing the Earth to remain composed even as deep forces continue their patient work. The slow drift of tectonic plates beneath ancient coastlines allows shorelines to evolve gently. Beaches widen, cliffs soften, and coastal plains expand over thousands of years. These changes are subtle enough that the land appears familiar from one generation to the next, even as motion continues beneath the surface. Tectonic plates help regulate the depth at which magma cools before reaching the surface. In many regions, magma never erupts at all, instead solidifying slowly underground. This quiet cooling strengthens the crust and releases heat gently, supporting long-term balance without visible activity. The movement of plates beneath large inland seas influences how salt and minerals are deposited over time. As water slowly evaporates and returns, layers accumulate patiently, forming stable geological features. These deposits develop without urgency, guided by repetition rather than force. Tectonic plates also play a role in shaping Earth's long-term soundscape, or rather, its absence of sound. Most plate movement occurs silently deep beneath rock and water, producing no vibration detectable at the surface. This silent motion reinforces the calm nature of geological change. As plates move, they subtly guide where long volcanic chains become inactive. Once a region drifts away from a heat source, volcanic activity fades gradually. The land cools, settles, and becomes quiet again, transitioning smoothly rather than abruptly. The slow interaction between tectonic plates and Earth's core contributes to the stability of the planet's magnetic field over long periods. While not directly driving it, plate motion influences heat flow patterns that help maintain balance deep within the Earth. These effects unfold gently, reinforcing continuity rather than disruption. Tectonic plates influence the way continents resist deformation over time. Older regions become stronger and more stable as they cool and thicken, allowing them to move as unified blocks. This strength supports calm motion, preventing internal fracture and preserving surface stability. The gradual rise and fall of land caused by plate motion helps create natural terraces and plateaus. These features form slowly as erosion and uplift remain in balance. The landscape settles into layered forms that feel stable and timeless, shaped through patience rather than sudden change. As tectonic plates continue their quiet movement, they do not move toward a final shape or completed design. Their motion remains ongoing, steady, and unhurried. The Earth continues to adjust itself gently, allowing deep processes to unfold while the surface remains calm, familiar, and at rest. Tectonic plates quietly influence the way Earth absorbs and redistributes long-term stress. Instead of allowing pressure to build sharply, the planet responds through slow bending and gradual movement. This steady adjustment spreads energy across wide regions, allowing the Earth to remain composed even as deep forces continue their patient work. The slow drift of tectonic plates beneath ancient coastlines allows shorelines to evolve gently. Beaches widen, cliffs soften, and coastal plains expand over thousands of years. These changes are subtle enough that the land appears familiar from one generation to the next, even as motion continues beneath the surface. Tectonic plates help regulate the depth at which magma cools before reaching the surface. In many regions, magma never erupts at all, instead solidifying slowly underground. This quiet cooling strengthens the crust and releases heat gently, supporting long-term balance without visible activity. The movement of plates beneath large inland seas influences how salt and minerals are deposited over time. As water slowly evaporates and returns, layers accumulate patiently, forming stable geological features. These deposits develop without urgency, guided by repetition rather than force. Tectonic plates also play a role in shaping Earth's long-term soundscape, or rather, its absence of sound. Most plate movement occurs silently, deep beneath rock and water, producing no vibration detectable at the surface. This silent motion reinforces the calm nature of geological change. As plates move, they subtly guide where long volcanic chains become inactive. Once a region drifts away from a heat source, volcanic activity fades gradually. The land cools, settles, and becomes quiet again, transitioning smoothly rather than abruptly. The slow interaction between tectonic plates and Earth's core contributes to the stability of the planet's magnetic field over long periods. While not directly driving it, plate motion influences heat flow patterns that help maintain balance deep within the Earth. These effects unfold gently, reinforcing continuity rather than disruption. Tectonic plates influence the way continents resist deformation over time. Older regions become stronger and more stable as they cool and thicken, allowing them to move as unified blocks. This strength supports calm motion, preventing internal fracture and preserving surface stability. The gradual rise and fall of land caused by plate motion helps create natural terraces and plateaus. These features form slowly as erosion and uplift remain in balance. The landscape settles into layered forms that feel stable and timeless, shaped through patience rather than sudden change. As tectonic plates continue their quiet movement, they do not move toward a final shape or completed design. The motion remains ongoing, steady, and unhurried. The Earth continues to adjust itself gently, allowing deep processes to unfold while the surface remains calm, familiar, and at rest. Tectonic plates influence how Earth quietly adapts to long-term changes in sea level. As oceans slowly rise or fall over geological time, the crust responds gently, flexing just enough to maintain balance. This interaction happens gradually, allowing coastlines and continental margins to adjust without strain or sudden transformation. The steady movement of tectonic plates beneath ancient river basins allows sediment to spread evenly over wide regions. As plates drift and settle, rivers respond calmly, depositing layers of material that build fertile plains over thousands of years. This slow collaboration between water and rock creates landscapes that feel settled and enduring. Tectonic plates help determine where deep underground caverns and porous rock layers develop. Gentle compression and extension create spaces where water can collect and move slowly. These underground systems form patiently, becoming quiet reservoirs that support surface life without visible change. The slow drift of plates beneath tropical regions influences long-term weather patterns in subtle ways. As continents move gradually, wind paths and rainfall zones shift gently. These changes unfold over such long timescales that ecosystems adapt smoothly, preserving harmony rather than experiencing disruption. Tectonic plates also play a role in how Earth stores and releases chemical elements over time. As plates move, rocks are buried, altered, and later returned closer to the surface. This cycle happens quietly, allowing elements to circulate through the planet without abrupt concentration or loss. The calm movement of plates beneath shallow continental seas allows wide limestone platforms to form. Tiny marine organisms build layers slowly as plates remain stable beneath them. Over millions of years, these layers harden into rock, preserving calm ocean conditions from a distant past. Tectonic plates influence the gradual shaping of Earth's interior layers. As plates move, pressure changes slowly at depth, encouraging minerals to reorganize into stable forms. These transformations occur without disturbance, supporting the planet's long-term internal balance. The slow motion of plates beneath volcanic arcs allows magma systems to cool and stabilize between periods of activity. Long intervals of quiet dominate these regions, with heat dispersing gently into surrounding rock. The Earth prefers these extended periods of calm over brief moments of activity. Tectonic plates help maintain Earth's gentle curvature by redistributing mass gradually across the surface. As continents drift and oceans open or close, the planet adjusts subtly, preserving its overall shape. These adjustments are continuous and quiet, reinforcing stability rather than altering it. As tectonic plates continue their patient movement, they do so without intention or destination. Their motion remains steady and balanced, guided by deep forces that act quietly and consistently. Change continues gently, allowing the Earth to remain alive with motion while preserving a deep, comforting sense of calm beneath every landscape and ocean. Tectonic plates quietly influence how Earth absorbs long-term changes in surface pressure caused by oceans, ice, and sediment. When large areas become heavier or lighter over time, the crust responds slowly, bending just enough to maintain balance. This gradual response happens over thousands of years, allowing the planet to adjust smoothly rather than abruptly. The steady movement of tectonic plates beneath ancient continental shelves helps preserve wide, shallow marine environments. These shelves form and remain stable because plate motion occurs gently below, allowing sediments to settle evenly and ecosystems to flourish without disturbance. The calm persistence of these environments reflects the slow rhythm beneath them. Tectonic plates guide the formation of deep underground heat reservoirs, where warmth accumulates and disperses slowly. These reservoirs release energy gradually into surrounding rock, preventing sharp temperature differences. This gentle heat exchange supports smooth motion rather than sudden geological change. As plates move beneath regions rich in groundwater, they subtly influence how water is stored and released. Rock layers tilt and compress slowly, guiding water through hidden pathways that remain stable for centuries. These underground flows develop quietly, supporting surface life without drawing attention to their existence. The slow drift of tectonic plates beneath temperate regions influences soil depth and composition over long periods. As land rises or settles gently, erosion and deposition remain balanced, allowing fertile soils to develop patiently. This slow shaping creates landscapes that feel settled and enduring. Tectonic plates also affect how Earth's crust responds to long-term erosion. As rivers and winds remove material from the surface, plates adjust subtly below, redistributing mass to maintain equilibrium. This quiet compensation allows landscapes to change smoothly rather than collapse or fracture. The gradual interaction between tectonic plates and mantle material allows pressure to equalize over vast areas. Instead of concentrating stress, motion spreads it evenly, reducing the likelihood of sudden release. This even distribution contributes to the planet's overall calm and resilience. As plates drift beneath large forested regions, they do so without disturbing surface stability. Trees grow, ecosystems mature, and climates cycle while deep motion continues unnoticed. This separation of timescales allows life to remain calm even as the Earth reshapes itself slowly below. Tectonic plates influence the formation of long-lived plateaus by supporting gradual uplift, followed by extended stability. These plateaus remain elevated for millions of years, not through force, but through quiet balance between uplift and erosion. The land settles into a steady state that feels timeless. As tectonic plates continue their patient movement beneath the Earth's surface, they do so without urgency or direction. Their motion remains steady, guided by deep forces that act quietly and consistently. Change unfolds gently, allowing the planet to remain active while preserving a deep and comforting sense of calm. Tectonic plates quietly shape how Earth responds to long periods of stillness as much as movement. In regions where plates drift at especially slow rates, the crust experiences extended calm, allowing stresses to dissipate almost as soon as they arise. This creates landscapes that remain largely unchanged for millions of years, reinforcing the idea that stability itself can be an active, ongoing process. The slow motion of tectonic plates beneath inland plateaus allows elevation to be maintained without dramatic uplift. These high regions persist because the forces below them remain balanced, neither pushing upward forcefully nor allowing collapse. Over time, erosion and uplift remain in quiet harmony, producing landforms that feel settled and enduring. Tectonic plates influence how Earth stores water, deep underground by shaping porous rock layers gradually. As plates compress or stretch the crust over long spans of time, tiny spaces form within rock, allowing water to collect and move slowly. These hidden reservoirs develop patiently, supplying surface ecosystems without visible change. The steady drift of tectonic plates beneath polar oceans helps regulate the thickness and stability of ice shelves over geological time. As the seafloor rises or settles imperceptibly, water circulation adjusts gently, influencing how ice forms and melts. These changes unfold so slowly that balance is maintained without sudden shifts. Tectonic plates also guide the long-term formation of natural corridors through which animals and plants migrate. As continents drift and land bridges appear or fade gradually, species move at a pace that matches the geological rhythm. This slow reorganization supports biodiversity without forcing abrupt adaptation. The calm movement of plates beneath regions rich in volcanic rock allows heat to be retained deep below the surface. Instead of erupting, much of this heat warms surrounding material slowly, strengthening the crust and encouraging smooth motion. This quiet retention of energy prevents dramatic surface change. Tectonic plates help determine how long mountain ranges remain prominent. Once uplift has occurred, the plates beneath often stabilize, allowing erosion to work gently over millions of years. Mountains soften rather than collapse, transitioning slowly into rolling landscapes without sudden loss of form. The gradual interaction between tectonic plates and Earth's deeper layers influences how minerals crystallize over time. As pressure and temperature change slowly, minerals grow into stable structures without disturbance. These crystals form silently, recording Earth's conditions in a calm and orderly way. Tectonic plates also affect the long-term balance between land and sea by guiding slow changes in elevation. As land rises or settles millimeter by millimeter, coastlines adjust naturally. Bays form, shallow seas expand, and shorelines smooth themselves gently, creating environments that feel timeless. As tectonic plates continue their patient movement beneath the Earth, they do so without urgency, intention, or endpoint. Their motion remains steady and balanced, guided by deep forces that act quietly and consistently. Change continues to unfold gently, allowing the planet to remain alive with motion while preserving a deep, reassuring sense of calm. Tectonic plates quietly influence how Earth responds to long cycles of erosion and renewal. As wind, rain, and rivers slowly wear down the surface, the crust beneath adjusts almost imperceptibly, rising or settling just enough to maintain balance. This gradual compensation allows landscapes to remain stable over immense periods of time, even as they are gently reshaped. The slow drift of tectonic plates beneath ancient inland seas helps preserve wide, flat sedimentary layers. These layers settle patiently, one thin sheet at a time, forming calm geological records of past environments. Nothing interrupts their formation, allowing history to accumulate softly beneath the surface. Tectonic plates guide the long-term stability of Earth's interior pressure. As plates move, stress redistributes evenly rather than concentrating in one location. This spreading of pressure allows the planet to remain resilient, responding to deep forces with flexibility instead of resistance. The movement of tectonic plates beneath tropical regions subtly influences how heat is stored and released. Warmth rises slowly through thick crust, dispersing gently rather than escaping suddenly. This quiet transfer helps maintain consistent temperatures at depth, supporting calm geological conditions. Tectonic plates influence the way Earth's crust responds to long-term changes in vegetation and soil cover. As forests expand or retreat over geological time, the added or reduced weight affects the crust slowly. The response remains gentle, allowing balance to be preserved without noticeable surface change. The calm motion of plates beneath broad continental interiors allows groundwater systems to remain stable for thousands of years. Aquifers form and persist quietly, shaped by slow tilting and compression of rock layers. These hidden systems support life steadily, without drawing attention to the deep motion that sustains them. Tectonic plates also influence the way Earth's deep layers cool over time. As heat moves upward gradually, it passes through plates that act as buffers, slowing the release. This gentle cooling allows internal activity to persist without extreme fluctuation, maintaining long-term equilibrium. The steady drift of plates beneath ancient volcanic regions allows landscapes to transition calmly from activity to stillness. Lava fields cool, settle, and erode slowly, blending into surrounding terrain. The land softens rather than fractures, guided by patience rather than force. Tectonic plates help maintain the gentle curvature of Earth's surface by redistributing mass over millions of years. As continents drift and oceans open or close, the planet adjusts subtly, preserving its overall shape. These changes happen continuously and quietly, reinforcing stability rather than altering it. As tectonic plates continue their slow movement beneath the Earth, they remain guided by forces that operate evenly and without haste. There is no destination they are moving toward, only ongoing balance. Motion persists gently, allowing the planet to remain alive with change while holding a deep, steady sense of calm beneath everything that rests upon it. As this gentle journey through the quiet movement of tectonic plates begins to fade into the background, there is nothing left to follow and nothing left to understand. The Earth does not need attention to continue its slow, steady motion. Deep beneath the surface, plates will keep drifting patiently, guided by heat, gravity and time, whether they are observed or not. You may notice your thoughts becoming softer now, less defined, like continents slowly separating across millions of years. That feeling is natural. Just as tectonic plates do not rush toward a destination, your mind does not need to arrive anywhere either. Everything important can remain exactly where it is. Let your breathing stay easy and unforced. Allow your body to rest comfortably, supported without effort. Imagine yourself gently grounded, resting on a planet that has carried life calmly for billions of years, adjusting quietly beneath oceans, forests, and skies. Tectonic plates remind us that even the largest changes can happen without urgency. Movement does not have to be loud. Transformation does not need to be dramatic. Balance can be maintained through patience and steady motion. Thank you for spending this time with the Sleepy Scientist. Whenever the world feels busy or your thoughts feel heavy, you're always welcome to return to these calm explorations, where science moves slowly and rest arrives naturally. For now, let the quiet continue. Let the slow rhythm of the Earth remain beneath you, and allow whatever comes next to unfold gently in its own time, without pressure or conclusion. Good night.